Shall we start? Okay. So I am drawing a shape here. What is it? Parallelogram. The features? Features. Opposite sides are parallel and equal. It's masquerade, right? No? Correct or no? Okay. So how many pairs of opposite sides are parallel and equal? 1, 2, 2. How many? I mark. How many arrows? One arrow here, here, one. Okay. Then another set. Two parallel symbols. Okay. Height I have to now identify for this parallelogram. What should be the procedure? How do I identify the height of any polygon, especially this parallelogram? Are you able to see the cone? Then come shift, no? Shift. How to draw the height? From this down. Okay. So if this is cut line, this is height. I can name it as H. Can I draw many heights for the same parallelogram? Yes. How? Anywhere is the same if I draw? Anywhere? Same? Yes or no? Yes. So can I draw like this? And can I draw like this? Yes. So this is also the height. And if it is height, it should make 90-degree angle. Correct. So this is yet. So are drawn and they are drawn and they are drawn. And I gave this as 8. I asked you to find out this. Anyone remembers? Huh.
You have to first find the area of 10 into 4.
Yes.
And then have to then using that you can divide each from it, and then you will get the height.
Because the area can be calculated by, for a single parallelogram, heights can be two different heights. We studied that. So it is in two ways we can calculate the area, and using that concept, in case I consider one of them as base and consider that particular height, the product will be area. So 10 into 4, 40 square units is the area, and if I use, it should be other formula, if I use, it should be 8 into this corresponding height. If I call this as H2, this as H1. So H1, B1, H1 should be equal to B2, H2. B1 is 10, H1 is 4, product should be same as base 2 is 8, height. And that is why we got this as correspondingly 10 into 4 divided by 8. 5 units. So this is the advantage for a parallelogram. But for a trapezium, you imagine a trapezium is drawn in a similar manner. What is the difference between a trapezium and a parallelogram? In what way they? Only one side. Compulsorily, only one side is parallel. Other side is compulsorily non-parallel. So if I draw any trapezium, it can be like this also, or I can just make it this way. But observe only one parallel, opposite. They are not equal, remember. Not equal. None of them are equal. This not equal. These two also not equal. But considering only parallel, one set. So now coming to the concept of height. What kind of difference is there? For a parallelogram, we identified two heights. What about this? Can we still mark two heights? Is it possible in any way?
We can still mark two heights.
Two heights which are different in length, in the sense different in dimensions. No. Then only one. What is it due to mainly? If it is only one, we will try to draw. So if this is the parallel, what we defined height as? It is the distance, shortest distance between the two parallel sides, opposite parallel sides. So if height is drawn, it can be this way or anywhere, but parallel to the first height, whatever I give. Any number of heights, even outside I can draw. That time parallelogram we saw, no? Even I extend, it's coming again and again. Same way I have to parallelly go on extending, drawing the height. So this is height same, dimension same, the length h1 or h2 or how many ever, h1, h2, they are all equal. There is no difference between like heights. Heights means height, that's all. So if I try to draw another height, I cannot, because there is only one set of parallel line. So if I try to draw here this and this, it will be just one random line between the two lines. They are not parallel, so I can simply connect them using any distance. It is not shortest distance, because I cannot define any shortest distance there. They are not parallel, they are very random. So that is why for a trapezium, in the formula, whenever it refers to only one edge, it is the distance between the parallel edges. So we used that formula. What formula we used? Focus here. Okay. So what formula we used for area of a trapezium? No, I want others. We studied and we used already. Second question, I think we simplified. Area was given. One of the side, parallel side was half h into a plus b. Can you specifically tell what are these a and b?
First is parallel and second parallel.
Yes. So when we say the two parallel edges, the sum of the lengths of those two parallel edges into half into the height between these two parallel edges only, nowhere else. So where the height is drawn, it is between these two edges only, and their lengths are totaled. So no opening the bracket unless everything else is taken care of. So this is area. Correct, no? Clear, no? Formula. Very clear?
Yes.
So how to identify the lengths? It is only this and this for A and B. If this is A, this is B, or vice versa. Anything it can be, because we are considering sum. If I make it upside down now, it will become a boat kind of shape. So if that shorter one becomes the base, fine, no problem. Height will be distance between the two. Clear? Okay. So we are going to solve the next question. Here, what is meant by cyclic naming? Cyclic order of naming polygons.
Is it, and we draw that.
Wait. Anyone who can clarify this? Cyclic order of naming polygons. Somebody has given already the name of a polygon. If they have told A, B, C, D, what is my like whatever significant when I write the names? write the vertices. Wait. Cyclic order of naming means what? A, B, C, D should be the name given. Wherever I start from, I should go in the clockwise or anti-clockwise continuously without leaving any vertex. That's very important. If I skip any vertex, A, B, C, D, if it is named, it is random. Its name is different. So that is very, very important because you are going to construct quadrilaterals. If they say AB is so much, 5 centimeter, BC is so much, if B is written there, then the diagonal length you will be marking 7 or whatever given length. But given is side actually. So you are not supposed to name it any random manner. It should be cyclically. And in case the figure is not given for question number 3, how to do it? We have done third one now. Did we complete?
No, we did second one.
Third one is not done?
Third one.
Okay. So I will come back to say because I took that in the other class today. You mentioned about Pythagoras theorem, I remember. So how to name is important. They have given A, B, C, D and they have clearly told AB is perpendicular. So it is mentioned in the question AB is perpendicular and BC is parallel to AD. That is also told. So figure, if not given also, you should be able to find it. Clear? Is it clear? You should be able to do it yourself. Drawing the figure, seeing the question. So whenever you name, mark AB as a perpendicular. And whenever perpendicular, you know that it comes in the L shape. If you draw that, this is another way of drawing the same trapezium. If picture is not given, you can draw like this. This is perpendicular. That way also you can do. And this is given 40, this is given 47, this is 17, 8. Okay, 8. So we already did this. So for at least recording purpose, I will mention. So I have to draw another perpendicular. In case perimeter is not given, I cannot find AB. That's why you told that I can use Pythagoras theorem and find the length of this AB. Correct? No? Because here this is 40, this is 48, this is 17. So AB is, this is what is actually expected. Perimeter minus 40 plus 17 plus 48. Of course, you should write 40 as AD plus DC plus whatever, and then next step you write this. So this is given as how much? 120. Perimeter 120 given. So this is 105. Correct? No, we get it as 50. Now this one is easy question because we can find AB directly. But normally the question won't be like that. It will be having 17 given, this given, this given. You have to find the height yourself. So you draw one more perpendicular. Say you can call it by any name, DM, for writing purpose. Any name you give there and then use this for Pythagoras theorem. Pythagoras theorem deals with length of the sides, correct? No? So CD square minus CM square is DM square. CD square, hypotenuse square, is sum of the square of these two sides. So I can subtract hypotenuse square minus base square is equal to altitude square. So this is 17 square minus this is 8. We have seen already. This is dm square is to be calculated. H. That is the reason we want to find H. So dm square. So here this other day we calculated, I am not repeating. So this is 225 dm square. Dm will be square root of 225, which is 15. So if directly given, well and fine. Otherwise, normally this calculation will have 2 marks. So for 2 marks, maybe if this is asked, this is for 4 marks. But without this, you cannot proceed to calculation of area. Remember, correct? No? So now area calculation can be done. How? Same formula, whatever that time we discussed. I will write here because the board I don't know whether it's down. Area is half into height into sum of parallel edges. Half into 15 into 40 plus 48. Yes. When I consider base full length, I should consider, not that 40. If I consider, okay, I am just, that triangle is not part of the trapezium, then it is wrong. So here only for calculation of height, I have drawn that triangle and created that right angle triangle to find the height. Otherwise, no need, isn't it? So this calculation, I hope everyone can do it. This should be done together. No question of clubbing any part from here, half of this coming out or something like that. So it should be together. 88 and then 15 into half, you have to cancel and then get the answer with the unit, square units. Correct? Okay. Moving to next question. Fourth question. It's about the quadrilateral. What is the formula for quadrilateral area? Okay, if I don't memorize, what I can do? I don't know. I can't memorize.
Ma'am, is it half into
I have always confusion. Say what is this rhombus area and then trapezium area and this quadrilateral area. That formula comes to this formula. What should I do? It is random quadrilateral. So draw any random quadrilateral. It shouldn't look like trapezium or parallelogram. It's random. Then. So when any polygon is given, as we are familiar with the rectangle, square and triangles, we can split the given polygon into these square or rectangle or triangle and then find the area. So let me split and make it into two triangles, the resulting triangles, triangle 1 and triangle 2. If I name this as triangle 1 and name this as triangle 2, the sum of the areas of these two triangles will be the area of the quadrilateral. Sure, no? So let me draw height. This has a specific name. We discussed offset. We discussed, actually this looks like 90 degree. So I will draw here. May not be 90 degree, it may go out also. I don't know. So the green ones are two heights. If I consider this as H1, this as H2, and the white, whichever is drawn as D. This is D, diagonal D. Then, without memorizing the quadrilateral's area formula, can we reach at the area? So, area of the quadrilateral is equal to area of triangle 1 plus area of triangle 2. So area of triangle 1 is half into base into H1 plus half into base into H2. Here H2 we mark for bigger triangle. Triangle 2 is this original one, not this full, this. Can you visualize that? If I close this first, whatever, that part is one triangle, and if this is closed, this is half into base, if I consider this as common, half into base, A into B plus A into C is equal to A into B plus C, distributive property. So if I take out this half into base and write something inside, what will be there? H1 plus H2. Correct, no? So this is the formula and this base is diagonal. For any quadrilateral, the diagonal which is drawn by us, given diagonal, corresponding offset. So this is offset actually, H1 and H2. It's also called, we cannot say it is height of the quadrilateral. It is not height of the quadrilateral. It is height of the triangle which is split into the quadrilateral which is split into two smaller triangles. So it is not actually like how do we refer that parallelogram's height? No. Trapezium's height. This is not like that. That's why that special word offset. Correct? Understood? No, the difference between that height and the two heights we consider today. Parallelogram has two different heights. That's why we use the word corresponding height. In trapezium, we don't normally use the word particularly to this base because any height will be the distance between the two parallel sides because it has only one pair. Here, height means it is sub height, a kind of, we can say junior height. So we have to add the dimensions given. They have given the dimensions. Can you tell what are the dimensions? Half. What is this length given? 24, no? Okay. 24 into the other two heights are marked 30, another is 8. So you have to calculate that value, that's all. Correct, no? Sorry. Plus. So only that inserting the value and calculating when everything is directly given. Any confusion in this? No, right? And while doing so, please check the units. Sometimes height will be given in centimeters because they speak about some river and then one road. In terms of meters, they speak only the distance between those two, this one in centimeters. We cannot rely on that. So we have to double check any formula. Whenever we insert, we have to see that units are same. Correct? Okay. So you can copy that from the PDF PPT. Moving to next question. Fifth question is direct. Can you try it as it's already solved in PPT? You can try it yourself first, then check with the PPT whether your answer and method matches. It is two diagonals are given, both in centimeters. One is 7.5, another is 12. So you have to use it in the formula half into D1 into D2. Do it, okay. Question number 6. Rhombus, how do we draw the rhombus first? Basically, plus first, remember, because that avoids confusions. Often we think that rhombus is looking like a square or more of like something else, rectangle. To avoid that confusion, let us for a rhombus, we used two formulae for area, which is often forgotten by students and as well as like anybody who is attempting question on that. We often forget that it is a parallelogram. We somewhere relate it to kite. We think that kite is also a parallelogram often. Is it? Kite is not a parallelogram. If you observe kite, upper side one isosceles triangle is there. But if this is isosceles, but the lower one is isosceles but not congruent. So if kite is to be drawn, we draw this kind of plus first. And then this is isosceles, Lower one also is isosceles, but it is not congruent to the first one. It is different. So they are not actually, it's not a parallelogram because the opposite edges also are not equal, not parallelograms. Parallelograms, basic thing is opposite sides parallel and equal. That is not there in kite. So this one is parallelogram important. And the side of the rhombus becomes the base of the parallelogram. Because I can tilt. If I see from this end, it is something like what I do that time. Any parallelogram, if I extend the parallel edges are these. If I extend the parallel edges, whatever I am getting is the height. One of the height can be drawn. So these are the two parallel edges, and the other one is again parallel. Two sets of parallel. That is why it is a parallelogram. This in 6th standard it is learned features of quadrilaterals. So two opposite sides are mutually parallel. And now I want somebody to explain why the height of the rhombus is only one, in the sense I cannot get, in parallelogram we saw that there are two heights, generally any parallelogram. Today only we discussed. This is a parallelogram, and if one of the height is this distance between one of the parallel sides, another height is, if I extend this also is another height. But here, whichever way height is drawn, it is not different. If this is short, this is long. That is only for generally any parallelogram, not for rhombus, I say. I am saying it is true. I want the reason from your side. What is the reason? That heights are equal. Whatever height is drawn, they are equal.
Because all sides are equal.
Yes, correct. Because all the four sides are equal. I have defined this length, no? Parallel, correct. But this one is, if it is 6 centimeter, this is 6 centimeter, this is 6 centimeter. So all the four edges or sides of the rhombus are equal, no? So they are equal as well as parallel. Only parallel means parallelogram can have two heights. But here equal is additional feature, so we won't get heights different. If somebody gives one of the height to any side, that side is base, and the height whichever is given is the height of that particular rhombus. It is only one height. So if I try to draw this way height, and this I will just shade it so that you can identify. This is H. Then obviously I can draw another height like this for the same rhombus. This is another H. And from the other opposite vertex also I can draw. These are the two vertices from I have drawn. From here also I can draw. See, it comes outside. But still it is the distance between the two yellow parallel lines. These two lines I considered now. That time I considered the distance between the yellow lines only. This is also yellow lines only. Now distance between green lines, if you draw, this also will be equal. This 1, 2, 3. Likewise, this also will be equal. This another height, they will be equal. So that is the beauty of rhombus. Any height anywhere drawn is equal. Therefore, its base, the base is this from here to here. Correct, no? Rhombus, I can call this as base. The yellow line from here to here is the base, and this is the height. So I can calculate the area using base into height. Even if only one diagonal is given, I can calculate the other diagonal using something else. Can you say how? Okay, in that question, This is given as 5. Correct, no? Side. If you check, side is given as 5. So this is base also. Height is how much? Can you say? Corresponding height is given. What is that? 4 point? Okay. This is the height. 4.8. 5 into 4.8 is area. Correct, no? Base into height. Now without that I can find out. This is given as 4. Correct? 4. What is the D value? 8. Diagonal how much? 8. Okay. So I will name this as 4, this as 4. From here to here 4, here to here 4. 8. Correct, no? So can you find out this? This. How? That is okay. That is there. Apart from that.
Pythagoras theorem.
Yes, Pythagoras theorem. I can find D2 also. Because I am not willing to use this base into height. Let me see. Why can't I use half into D1 into D2? I can use because D1 is given A. This is 4. This is hypotenuse. I should know. So you remember 3, 4, 5 Pythagorean triplet. So 5 square minus 4 square is what? 9. No. So this will be 3. Correct, no? So even if they don't give height, I can calculate the other diagonal using Pythagoras theorem. Other diagonal because side is hypotenuse. 5 square minus 4 square is 3 square. So half of the diagonal I got means next full, no? D2 is how much? 6. D1 is 8. They only gave. So I used 4, 4. 5 is side. Side means hypotenuse. Find D2. D2 is 6. Now 8 into 6 into half. Area. Half D1 D2. Correct, no? Are you with me?
Yes, ma'am.
So this is the way we can see it in a different way. Use the Pythagoras theorem even without the height given you can calculate the D2 and then use area calculation. Otherwise use this. This is parallelograms area formula. So you got parallelograms area. How much is this? 24. Quick you should be in multiplication. 24 square units, right? Square centimeter. Next, use it in half D1 D2. Half D1 D2 is 24. Area. Base into height. Base into height is area. Half D1 D2 is area. So I used base into height to find the area. Now, I know that area is same, no? Parallelogram, no? Same parallelogram. So half into D1 is 8. Correct, no? D2 is not known. 24. Now, 4 into D2 is 24. How much is D2? 6. So this difficulty can be avoided if you are very well familiar with the Pythagoras theorem. But sometimes it is not possible if this is not a perfect number. Square root you have to find, no? If this is 5, 4, 3, okay, you know. But if I give here 5.8 side, then this is 3.2. How much time is required to find the square of 5.8 and 3.2? You cannot use, right? But at least when you see certain numbers which are very familiar to you, you should be able to at least guess, okay, this is the how like Pythagoras theorem I can use and find the other diagonal. Then I can find directly the area. They want us to calculate area, right? They have given only one of the diagonal. But formula says both the diagonals needed. But they have given the side. Side is hypotenuse. So you can use Pythagoras theorem to find the other diagonal and then reach at the answer yourself. Without even using this formula. Normally this is not understood by many because they often think that rhombus means half D1 D2 from where base into height comes. Parallelogram also, you should remember it is parallelogram also. So you have to dig deeper and think in a different way. So often students ask, should we draw the rough diagram? I draw different rough diagram so that I can understand it better. Just a rough diagram, it is not a permanent one. Obtuse angle may look like acute. Short 4 centimeter may appear longer than whatever 2 centimeter marked in the figure, but it gives so many insights into the question. That's how I understand the question. Otherwise, geometry becomes what? Can't digest it. So you have to look at the problem in different ways. Okay, so I have solved already. Please go through that and do complete fourth one. Okay, so next you can complete the exercise and copy and come, but never see the notes incomplete. I don't want to see. Whenever it is there, notes, whatever I teach should be there. You need not draw all this whatever extra I have drawn and all. What is given in PPT should be written neatly. Okay, and do that the question. Also, example 1, example 2, example 3 in the textbook should be studied by you. It is in which page? Page 176 and 177 has example 1 and example 2 and 3. Study that, how the formula is used, you learn, and then we can apply. It's needed for further classes. In case any doubt, you can ask. Those